Hi guys, in this video I'm going to walk you through how to answer every single question from paper 1, the arithmetic paper from the Year 6 SATs in 2023. Let's get started. Question 1, 707 take away 10. So this is just a simple subtraction, and although you could use column subtraction, you should actually be able to do this in your head. You're just taking 10 away, so it's understanding which digits are going to change. Now if you look at your tens column, you've got a 0, so you've got 0 tens, but you could also look at this as 70 tens. Okay, so if you've got 70 10 and you're taking away 1 10, you're going to be left with 69 tens. This digit doesn't change. Okay, 707 take away 10 is 697. If you're not confident with that, then it is going to be a simple column subtraction. So I'm writing the answer in there. So 707 subtract 10. Make sure that you line your digits up correctly. That's going to be the most important bit. 7 take away 0 is 7. 0 take away 1 we can't do. So that becomes a 6. That becomes a 10. 10 take away 1 is 9. 6 take away nothing is 6. If you do need help, make sure, see my 7 doesn't look very good because I've done it on a computer. Make sure when you write it in that it's very clear that it's a 7. If you're stuck on calculating, I have lessons on this on my number calculation ebook, or I've got my Arithmetic Academy, which is just 6 short lessons that runs through all the important arithmetic calculations, the adding, subtracting, dividing, multiplying, and then a bit on BODMAS. Okay, let's go on to question 2. Here we have something equals 6,138 plus 456. The important thing about this is to understand that when we have an equal sign, all it means is that everything on this side of the equal sign is the same as everything on this side of the equal sign. We're very used to seeing a number sentence, then an equal sign with the answer, but that doesn't, mathematically, it doesn't matter where your equal sign is as long as both sides of it have the same value. So for this, you could literally just rewrite it. And for some of you, if you wrote it, or if the question was written like this, it might be more obvious to you what you have to do. They're both the same thing, okay? So you're just adding. So this is a simple column addition question, making sure that you line up the digits correctly, that you put the 400 under the 100, the 5 tens under the 3 tens, and the 6 ones under the 8 ones. Okay, and then we're going to now just add. So 8 and 6 is 14. 3 and 5 is 8, plus the carried 1 is 9. 1 and 4 is 5. 6 plus nothing is 6. Please remember to write this number carefully in the answer box. That's it. Question 3 is a short multiplication. 4 times 702. So you're simply going to write out 702 and multiply it by 4 using the formal written method of short multiplication. So once you've lined up your digits correctly, you're just going to multiply. So 2 times 4 is 8, 0 times 4 is 0, and 7 times 4 is 28. And that's it, a simple short multiplication. There are lessons on short multiplication in my SATs ebook, the number calculation ebook, or in my very short Arithmetic Academy course. Question 4, something equals 8,005 plus 408. This is exactly the same as our previous question, where the answer, in inverted commas, is before the question. It's actually not an answer, it's just saying this value is the same as this value. So if we were to rewrite it as 8005 plus 408 equals, that might give you a bit more of a clue of what you've got to do. And you've just simply got to add the two numbers to find the other value. So the most important bit with any of these calculations is you are lining up the digits of the same value in the same column. So our hundreds, our tens, and our ones are all in the same column. I highly recommend that you use the squares on your page to do this. They're nice and easy way to make sure that all your digits are lined up if you just write a digit in each square. Okay, and then you can just simply start to add. 5 and 8 is 13. Just made that a little bit neater. 0 and 0 is 0, but plus the 1 is 1. 0 and 4 is 4, and 8 plus nothing is 8. So 8,413. Of course, you could have calculated this mentally as well, because all you are adding is the 5 to 408. So you could have done that mentally as well. Obviously, if you're doing things mentally, it will be quicker, and you do have a limited time to answer the questions, but accuracy is also very important. So if you're not sure, if you're not 100% confident, then just do the written method. Question 5, 2 times 4 times 30. Okay, so for this question, we've got three numbers we're multiplying. The most important thing to be aware of is when you're multiplying three numbers or four numbers or five numbers, it doesn't matter what order you multiply them in, you can switch them round. But in this one, I'm just going to multiply it in the order it's in. So I'm going to multiply these two first. 2 times 4, which is 8. So this is going to become 8 times 30. And then for 8 times 30, you might want to do a short multiplication. But actually what I would be doing is, if I know what 8 times 3 is 24, then I know that 8 times 30 is just going to be 10 times bigger, because 30 is 10 times bigger. So it's 24 tens, or 240. And that's my final answer, 240, which I must make sure I put down into my answer box. So my final answer is 240. Just to have a quick demonstration to you, if I rub all that out, if I had decided that I wanted to do it in this order and do 2 times 30, that's 60, and then times it by 4, well, I know that 6 times 4 is 24, so 60 times 4 is going to be 10 times bigger. It's also 240. Question 6. Okay, we've got another question where the missing value is before the number sentence. So just think about this as the other way around. 10 times 96 equals, or 96 times 10 equals. Doesn't matter what way round it is. As we're multiplying by 10, there is no need to do a written multiplication. You do need to know how to multiply numbers by 10, 100 and 1000, and to divide them as well. When we times something by 10, we simply take our number and we think about the value of each digit, and we're going to move it over to the left. So 96 becomes 960, but let me just demonstrate what I mean by the value. So I've got a 10 and I've got a 1, 9, 10, 6 ones. And if I was writing this a place value chart, the next value would be hundreds. Now when you times something by 10, you just move everything over 1 to the left. So my 9 tens becomes 9 hundreds, my 6 ones become 6 tens, and then I simply fill the last gap in with a placeholder. So my final answer is 960. Question 7, 7.8 plus 6.953. Now when we are adding decimal numbers and you have a number that has more decimal places, what is really important is the lining up of the digits. Now when we're lining up digits with decimal numbers, think about your ones first. Okay, so make sure you line up the ones first. So if I write 7, and I'm going to give my decimal its own square, 0.8. You don't need to, but I do just for complete clarity. Then the next number 6, I'm going to make sure I put it under the 7. Okay, so these are not digits I'm going to make sure I've lined up, because that will help me to line up the others correctly. So my 0.9, my 9/10 is under my 8/10. I've now got these 2 extra digits because I've got 500ths and I've got 3000ths. Remembering to write in my operation, I'm adding. Now, the next thing you need to do is to give both numbers the same number of decimal spaces. So I want my 7.8 to have 3 decimal places as well. It's only got 1 at the moment. So I just put in placeholders, zeros. That does not alter the value. 7.800 is exactly the same number as 7.8, but obviously we don't waste time by putting the extra zeros in. But for a calculation where you're going to be adding or subtracting, I highly recommend you put in all of the digits to all of the placeholders so that they both have the same number of digits. It's not as important in an addition as a subtraction, but I just do it as habit. So now we can start to add. 0 and 3 is 3, 0 and 5 is 5, 8 plus 9 is 17. Remember to put your decimal point in, sorry. The 17, I need to carry my 1 over to the next column, which is now my 1s. Then I have 7 and 6 and 1, which makes 14. And that is my final answer. So the important bits in this question are to make sure your digits are lined up, go by the 1s to help you, and the decimal point should be over each other. And then make sure both numbers have the same amount of decimal places. So I've made these both I've made both numbers have 3 decimal places, and then I can write my answer in the answer box, making sure it's neat and each digit is clear. Question 8, another question with the answer first. Okay, so there's quite a few in this paper. So remember, if you wrote this the other way around, 8,217 take away 5,463 equals, it would be a lot more obvious. It's just really getting your head around the fact that it does not matter which way round where the equal sign is. Both sides of the equal sign are the same value. So what we need to do is to do a subtraction, and we just need to make sure our digits are lined up. I also just like to make sure I write in my operation to remind me what I'm doing. And then now we can just start to subtract. So 7 take away 3 is 4. And this is really just showing that you know how to subtract. 1 subtract 6 we can't do. So if you are a bit shaky, 11 take away 6 is 5 with your subtraction method, then you do need to check out either Arithmetic Academy or my number calculations ebook, because this is a very important skill. Not only in the arithmetic paper, but in the reasoning paper, there will be questions where you have to subtract. So I can't do 1 take away 4, so I'm going to make this a 7. I'm going to make this an 11. 11 take away 4 is 7, and 7 take away 5 is 2. So I've got my final answer, and remembering to write the final answer in the answer box where it is indicated. Question 9, 450 divided by 9. So for this question, it is a short division. You can do this mentally. If you can't do it mentally, then you need to put it into a bus stop. So I'm just going to pop it into a bus stop quickly. But you could also just use known facts. So what I'd be looking for in this number is, I can see a 45 here and a 9. So I would be using my understanding that 45 divided by 9 is 5. So 450 divided by 9, as my dividend, 450 is 10 times bigger than 45. I know my answer is going to be 10 times bigger. Okay, can you see that pattern? This is something that you do need to know in year 6. It saves you a lot of time if you can just do it like that. Otherwise, you can do it in short division. 9 into 4 doesn't go. So that's going to become 45 now. 9 into 45 goes 5 times, and 9 into 0 goes 0 times. Both ways you've got a 50. The goal is really to be able to spot this and do this mentally, but if you are not sure, then definitely use a written method, just for accuracy. Question 10, 8 times 65. So this is just a short multiplication. I'm going to just make sure that you set it out correctly and that you do your times tables accurately. So 5 times 8 is 40. 6 times 8 is 48. Plus your 4 is 52. So this is really just knowing your times tables, being able to add correctly and being able to lay it out correctly. So the final answer is 520. Question 11, 2,800 divided by 7. Like the question a couple of questions ago, this one is a division. It's a short division, but also if you just can use known facts, if you can spot any known facts in here, then you don't even need to use the bus stop. So what I can spot here is the number 28 and 7. So my known fact is 28 divided by 7 is 4. And I can see that my number 2,800 is 100 times bigger. So therefore, 2,800 divided by 7 is going to be 100 times bigger. So it's going to be 400. Okay. So 280 divided by 7 would have been 40. If you need to use your short division method, or 7 doesn't go into 2, we then carry the 2 over. 7 into 28 goes 4 times. 7 into 0 doesn't go. 7 into 0 doesn't go. You can see it's the same answer both times, 400, but the first way is quicker. So if you have got a really good grasp of number properties and known facts and how to manipulate numbers like that, you'll be able to answer the question with more speed. But if you have to choose speed and accuracy, accuracy is obviously the most important. However, if you can do things quicker with accuracy, then you're more likely to get through the paper and to pick up as many marks as possible. Question 12, 801 subtract something equals 795. Now here it's, if you understand how subtraction works, you will know that these two numbers are interchangeable. Okay, so when you are subtracting, the first number must stay the same. That can't be swapped around because that's the biggest number in this number sentence. But these two numbers can change around. And I'll demonstrate like this. 10 take away 1 equals 9. And I can swap these two digits around. 10 take away 9 equals 1. That's how subtractions work. The number after the subtraction can swap with the answer. So we could write this out as 801 subtract 795 equals, and that's probably going to be a lot easier to solve. Okay, now you could either count up from your 795 to 801. You could use a number line, or you can just use a column subtraction. So I'm just going to show you with a column subtraction, or you could literally count up, even if you have to count up in your fingers. I know sometimes there are teachers that don't like children counting up on their fingers. I say count up on your fingers. Your fingers are manipulative, and that's how you learn. Okay, so if I was counting from 795, so I'm literally got my hands out now, which you can't see. I'm counting up 796, 797, 798, 799, 800, 801. I've got 6 fingers. That's my answer. That's pretty quick, and I'll probably be able to do that quicker than writing out this column subtraction. So 1 take away 5 I can't do. I can't take anything from the 0 yet, so that's a 7, that's a 10, that then gets crossed out, that becomes a 9. 11 take away 5 is 6, 9 take away 9 is 0, and 7 take away 0 is 0. That took me so much longer, didn't it, than just counting up from 795 to 801. Okay, another way you could have done it is 795 plus 5 gets me to 800, plus another 1 gets me to 801, that's 6. Okay, so there's a few different ways to do that question, but the main thing is understanding that you swap these two digits round so that you can see you're just finding the difference between 801 and 795. Question 13, 2,700 divided by 3, sorry. So here again, I'm just looking for, when you've got these these divisions, these short divisions, just look to see if there's any patterns. I can see that I can use the fact 27 divided by 3. You're looking for the ability to use known facts. I know that 27 divided by 3 is 9. And if I look at how much bigger this is, it's 100 times bigger. There's 2 zeros, that means it's 100 times bigger. That means this answer is going to be 100 times bigger. So 2,700 divided by 3 is just going to have an answer that is 100 times bigger than my 9. Okay, see, I've added my 200s there. If I very quickly do that in a bus stop, 3 into 2 doesn't go, 3 into 27 goes 9 times, 3 into 0 goes 0, and 3 into 0 goes 0. Both the same answer. Okay, so 2,700 divided by 3 is 900. The goal is to start looking for those known facts and then to use your understanding of multiplying and dividing by 10 and 100 and 1,000. Question 14, 2/7 times 5/9. So we've got our first fraction question. Now, when we multiply fractions, we don't need to worry about doing anything to our denominators. Multiplying fractions is a lot easier than adding or subtracting them. It's just about remembering those facts. If you are a bit shaky with your fractions, there's the fraction SAPS ebook, but it's also my Focus on Fractions course, which is just a short course. It's got 6 fraction lessons that are all focused on this arithmetic paper. So we're just simply going to add across the top, add across the bottom. Multiply across the top, multiply across the bottom. 2 times 5 is 10. 7 times 9 is 63. And it is that simple. Your answer is 10 over 63. Question 15, 747 divided by 9. Now, the first thing I do is look for known facts, but because there are no zeros here, I'm not able to find a number that has been made 10 times bigger or 1,000 times bigger. I'm going to need to use a short division here, sorry. So we are going to write our dividend inside the bus stop and our divisor outside the bus stop. So I always do look for the quicker way, and sometimes it is just a case of solving it using the method. So 9 into 7 does not go. So I need to carry that 7 over. It's my remainder. I've now got 9 into 74. So that goes 8 times. So this is really about knowing your tables. If you need to, if you think, oh, I'm not sure if I'm not too good at my 9 times table, just jot your 9 times tables down quickly. So that's what I'm going to quickly do now. There is absolutely no shame in having to jot things down, even if you are normally quite good. Sometimes we get a bit nervous in a test situation. Just jot the numbers down if it makes life easier and you're going to be more accurate. So if I look down 9 into 74, if I look down my list, I can see, if I just use my flashlight there, 72 is the biggest number I can go in. 81 is too big, so that's 8. Okay, so 72 and 74, what's the difference there? There's a difference of 2, so that's what my remainder is. Then if I look down my list again, 27 is right there, it goes in 3 times. So I know there's no remainders, it goes in 83 times, and that's my final answer. Question 16, 3/16 plus 5/8. Okay, we've got some another fraction question here. The arithmetic paper is usually full of fraction questions. First thing to note is we're adding, so we need our denominators to be the same. So my first step is always to check if the smaller denominator can be converted to the bigger denominator. So can I change 8 to 16? Yes, I can. 8 is a factor of 16. 16 is a multiple of 8. So I can just change this smaller fraction, find the equivalent fraction of 5/8 so that it has a denominator of 16. That's the first thing I do. So do check out my Focus on Fractions short SATs revision course, or if you want lots of lessons on fractions, then the Number Fractions SATs ebook. So let's go through how I would do this. So I'm going to rewrite each fraction out. So 3/16 is going to stay the same. And I want to change my 5/8. I want to find the equivalent fraction. So 8 would be multiplied by 2 to make 16. So 5 will be multiplied by 2 as well. So that's 10. So now that I have two denominators that are the same, I know I can find my answer. And my answer is also going to have a denominator of 16. So I'd almost just write that in. Now all you need to do is to add your numerators to find your answer. So you just literally add along here to find your answer, and 3 and 10 is 13. Okay, and that is your final answer. Remember to write it in your answer box nice and clearly. Please write it like that and don't write it like this. Okay, sometimes they will accept it, but there may come a point where they decide not to accept that as a correct way of writing fractions. When you're doing fractions in school, sometimes because you see it on a computer screen, lots of worksheets and computer programs don't put the fraction line in correctly like they do here, and you see them like a slash, but please do write your fractions like this. Question 17, 0.3 divided by 10. Now this is a question that you should be able to do mentally. It's not one that you need to use a short division box for. I think I mentioned earlier that multiplying by 10, 100 and 1,000, as well as dividing by 10, 100 and 1,000 are skills you need to actually be able to do in year 5. You need to be able to understand what you do to the digits without having to do any kind of written calculation. So all you're going to do, if you're dividing by 10, remember your number's going to get smaller when you divide. And when your numbers get smaller, if you think about a place value chart, your digits move to the right. And if it's by 10, it moves by 1 space. So if I was to write my 0.3, and if I was to label the values, so my 0 is how many ones there are, my 3 is how many tenths there are. So that's how many tenths there are. Okay, the next column, I'm going to leave a gap just because I haven't got a lot of space on my computer, would be how many hundredths there are. How many hundredths there are. And then the next one would be how many thousandths there are. Okay, I'm not going to do a proper lesson on this now. There are lessons on this in my resources in my Pocket Private Tutor shop, just for quick demonstration purposes. There's my 0.3. If I visualize this becoming 10 times smaller, everything moves over to the right. Remember, it's moving to the right because it's becoming smaller. My 3 tenths is actually going to become 3 hundredths now. My 0 ones is going to become 0 tenths now. You cannot leave your ones column empty. Okay, so we can't just leave it like that. I need my decimal point, and my ones column, we're going to use a placeholder. We're just going to put a 0 in there. Okay, so 0.3 divided by 10 becomes 0.03. If you have lots of practice with this, then you should be able to do this mentally in your head without having to write it down. But if you do get stuck, just write the number down, write the place value headings, and then move each digit however many spaces it needs to go. And this works for multiplying or dividing. Question 18, 1/3 plus 2/6 plus 5/18. Okay, so remember our first thing we need to spot is that the denominators are not the same. I always look at the biggest denominator and I think about whether the other ones can convert up. 6 is a factor of 18, so that means I can multiply that to make 18. 3 is also a factor of 18, so I can actually change all of these to 18. So I'm going to convert all of these. I'm going to rewrite them out as fractions of 18. So every fraction in my original sentence is now going to have a denominator of 18. So the third one we can just write in. It's not changing, is it? 5/18 is just staying as 5/18. So let's look at my 1/3. I need to look at the 3 and the 18. 3 multiplies by 6 to make 18. Whatever I do to the bottom, I do to the top. So 3 times 6 is 18. 1 times 6 is 6. Let's look at 2/6. 6 multiplies by 3 to make 18. Whatever I do to the bottom, I do to the top. So if 6 times 3 is 18, 2 times 3 is 6. So we can actually see that 1/3 and 2/6 are the same fraction. Okay, because 1/3 times 2 is times top and bottom by 2 is 2/6. These are equivalent fractions. So we've now got a new number sentence, but because my denominators are the same, I can add them. I know that my answer is also going to have a denominator of 18, so I could even write that bit in now. And then all we need to do is to look at our numerators now, and we're going to add along the top here. So we're doing 6 plus 6 plus 5. 6 plus 6 is 12, plus 5 is 17. Okay, we have a proper fraction here. The numerator is smaller than the denominator, so we don't need to do anything else. Our final answer is 17 over 18. I also know that because 17 is a prime number, that I can't simplify this anymore. 17 is prime number, 18 is not in the 17 times table, so I know that that answer is the final answer. Question 19, 29.5 take away 16.125. Okay, so we've just got a subtraction here again where we have different decimal places. We've got only 1 decimal place here and 3 decimal places here. Most important thing is to line up the digits. I'm just going to zoom in so that I can write it in with a bit more accuracy. So I'm going to write my first number in, 29. I'm going to give my decimal point its own square. And then the next number, I need to make sure that my 10s and 1s are lined up. So 29 goes over 16, okay? My decimal points need to be lined up. And then I'm going to put my 3 decimal places in. As in one of the, and I'm going to put my subtraction in. As in one of the previous questions, I like to give both numbers the same decimal places. So my 29.5, I can put 2 placeholders in, becomes 29.500. That doesn't alter the number 29,500. It's still 29,500. Sorry, it's still 29.5. The value hasn't changed at all. Okay, but now we can start to subtract. And this is really important in a subtraction because now I can see I need to do 0 take away 5, which I can't do. If you didn't have the zeros there, what I see a lot in the papers is people write 5 here and 2 here because they can't see they need to subtract anything. But now we can see we need to subtract 5 from 0, which we can't do. So we need to go to this 0. We can't take anything from there. So we are going to go over here. That becomes a 4, then that becomes a 10, and now we can make that a 9, and that's going to become a 1, and that becomes a 10, sorry. If this is confusing, then you definitely need to do either the Arithmetic Academy course or look at my numbers calculation ebook, because this type of calculation with decimals is really important. So now we can subtract. 10 take away 5 is 5, 9 take away 2 is 7, 4 take away 1 is 3. Decimal point, 9 take away 6 is 3, and 2 take away 1 is 1. And then we have our final answer, 13. And then please make sure you put your decimal point in very clearly. It doesn't look like a comma or an apostrophe. It's nice and clear, and all your digits are clearly written in the answer box as well. Question 20. Okay, here we have got a long multiplication, and we're looking for the formal written method for long multiplication. Now, when I am doing a long multiplication, I like to draw a line in. I like to leave 2 spaces, draw a line in, and then just draw another line in here. This is not essential. It's just something I like to do. It reminds me that I need to do 2 lots of multiplication. So I wouldn't do this in the paper, I'm just doing this for demonstration. So I've just written to the side that the first line is where I'm showing 508 times 4. The second line is where I'm showing 508 times 70. You don't need to write that down when you do a multiplication. That's just for demonstration purposes. Okay, I'm now going to start multiplying. Now, in a long multiplication, there are a few common errors that I see happen with how it's laid out. And I go through all of that in my numbers calculation stats ebook. There's a whole lesson on the formal written method of long multiplication if this is something you need help with. Other than that, it's actually your times tables you need to be good at. You are usually allowed one mistake with a times table, okay, but not anything more than that. And don't rely on that because they change the mark schemes every year. So 8 times 4 is 32. Now, this is something else. Some schools carry the 3 up here, which is a good idea. I carry it down below. It's just something I've always done. But if you carry it above, carry on doing that. 0 times 4 is 0, plus my 3 is 3. Now, what you can do is cross that 3 out so it doesn't get used in a calculation, the last calculation we do. 5 times 4 is 20. And I write that fully in. Now, when I go to my next line, I'm going to just use a different colour. I need to put a placeholder in. And we now do 8 times 7 is 56. Carry my 5. 0 times 7 is 0, but I need to add that 5. So that becomes a 5. I'm going to cross that carried 5 out. 5 times 7 is 35. Now that I've written all of both my calculations in, both my lots of multiplication, we're now going to add the 2 rows together. 2 plus 0 is 2, 3 plus 6 is 9. Now, if I didn't cross that 3 out, there's a chance I could have added that in by accident. That's why a lot of times you're told to put your carried numbers at the top, carried digits at the top. 0 plus 5 is 5, 2 plus 5 is 7, and nothing plus 3 is 3. So I have my final answer. You just need to make sure that you write that digit in very carefully, write that number in digit by digit very carefully. 3, 7, 5, 9, and 2. Question 21, 1/8 divided by 3. Okay, so we have a dividing with fractions question here. In year 6, you'll only ever be dividing a fraction by a whole number. Once you get up to year 7, you'll start dividing pairs of fractions, which is arguably a bit easier. Now, you might have heard of the keep change flip phrase. I do talk about this in my SATs ebook. The fractions ebook. I talk about how to divide pairs of fractions and using that phrase. Just now, I'm just going to show you very quickly how you can rewrite a division. And this works with any division actually. Dividing by 3 is the same as timesing by a third. So you just take the number you're dividing by, your divisor, and that becomes your denominator, and you just put a 1 above it. Okay, so any number that you're dividing by is the same as multiplying by that number as a fraction. It's called inverting it. So I can put my 1/8 like that. 1/8 times a third is the same as 1/8 divided by 3. To give you a quick bit of proof, 10 divided by 2 is the same as 10 times a half. Okay, when you're timesing, so 10 times a half is the same as half of 10. Okay, we know that both of those answers are 5. Okay, but if we change it to 1/8 times a third, it makes it a bit easier because we know that with fractions, when you're multiplying, you just multiply the top and you multiply the bottom. Okay, so 1 times 1 along the top is 1, and along the bottom 8 times 3 is 24. Okay, so it's as simple as that. You just multiply the top, multiply the bottom. But when you're dividing with a fraction, just take that number you're dividing by and pop that underneath a number 1. Turn it to a fraction. Question 22, 1 plus 2/7 plus 5/7. Okay, we are adding with fractions here, even if we have got a whole number. we need to make sure that our denominators are the same. So we've got two denominators the same there. Now there's a couple of ways you can do this. We could change our number 1 to a fraction as well. So we could change the 1 to 7/7. We could just start to add the numerators like that. Or you might want to just add your 2/7 and 5/7 and then add those two numbers together. So let's do the first way. So 7 is the denominator. So that means in my answer, 7 is also going to be the denominator. If I look along the top, 7 plus 2 plus 5, that makes 14. So I've got an answer of 14/7. Now I can see that is an improper fraction because it's top heavy. The number above, the numerator, is bigger than the denominator. So I do know that I need to change that in a moment. But let's just have a look at if we've done it the other way round. If we had just done 2/7 plus 5/7, then we would have had 1 plus 7/7. Okay. Either way, we still need to do some changing. But what I might spot with my 1 plus 7/7 is this is the same as 1 plus 1, which just makes 2. Okay, so if you've done it that way, you could have spotted that. Just so that you know, if you wrote 1 and 7/7 as your answer, you would get no marks. However, if you wrote 14/7, you could get a mark because that is the right answer. However, they are more than likely wanting you to convert it. In the 2022 SATs, they brought in some harder mark schemes where previously you could have been awarded a mark for the correct answer, even if it was an improper fraction. Some of the questions, they didn't allow that for you. So there's no predicting what they will accept in the mark scheme. So try, and if it's an improper fraction, to change it to simplify it and to change it to a mixed number. But 100% 1 and 7/7 would never get a mark. That would be incorrect, okay? Because you either write things as an improper fraction as 14/7 or change it. So 14 divided by 7 is 2. My answer is 2. That is the answer we're looking for, 2. It's the better answer, but there is a chance that 14/7 would get a mark. If you wrote 14/7 in the answer box and then you also try to convert it, and let's say you put 2 and 1/7 as a mistake, if there's an incorrect answer in the box, it will just be marked wrong. So the ideal answer we're looking for is this number 2. Question 23, 70 plus 48 divided by 6. Okay, if you have a number sentence and it's got different operations in, so we've got a addition and we've also got a division, then you are going to need to know the order of operations, sometimes known as BODMAS, as BIDMAS, as PEDMAS. It has various names, but it's the order of operations. There is a lesson on this in my SATs ebook, but there's also a lesson on this in my Arithmetic Academy, which is my shorter SATs revision course. Order of operations is an objective in the Year 6 curriculum, so you do need to know it. There is always at least a question, if not a few, which involve the order of operations. So you need to make sure that you're doing your division first. You need to make sure you do this part first. So 48 divided by 6 is 8. So we need to rewrite this as 70 plus 8. Okay, and then our answer is 78. If you had done 70 plus 48 first, and then you had written 118 divided by 6, you would have ended up with a number with a remainder or a decimal number. It would have been incorrect. So make sure you understand the correct order of operations so that if you have a question like this, you answer it accurately. Question 24, 3.2 times 12. So we are multiplying with a decimal here. There are a couple of different ways, well, there's lots of different ways to do this. There's 2 ways I would recommend. I would not recommend doing this in a column multiplication because there is a lot of room for error unless you have been taught how to do this properly. Now, one way you could do it is to do this as 32 times 12, and then afterwards divide your answer by 10 because you've made 32 bigger. 32 is 10 times bigger than 3.2, so you would need to divide your answer, or you can partition, which I'm going to show you how to do. So I could do 3 times 12 and then 0.2 times 12. That is the way I'm going to show you how to do. Now just partition each bit. So 3 times 12 is 36. Then for your 0.2 times 12, you're going to use a known fact. So you're going to use 2 times 12, which is 24. If you see 0.2 is just 10 times smaller than 2. So the answer is going to be 10 times smaller than 24. So it's going to be 2.4. Okay, can you see the link there? Then you just need to add these two numbers together. So we're going to do 36 add 2.4. And in previous questions, you've seen that if I have a number with decimal places, I want all my numbers to have the same decimal places. So I'm going to just make that 36.0 plus 2.4. And then I can just start to add. So 4, 8 and 3, remembering my decimal point. My final answer is 38. Remember to put it clearly, your decimal point in the box, 0.4. Question 25, 611 divided by 47. It's been written in the bus stop, so it's showing you that you do need to use this method. Now this is long division because this number 47, you probably don't know your 47 times tables, so it is long division. Now long division is an important skill to master. I have obviously got a lesson on division, long division, short division, interpreting remainders and division, all in my numbers calculation stats ebook. However, if it's just long division that you want to work on, I have a very short course on that and it's really good. It's just 5 steps and you'll be able to do long division, and it gives you lots of useful tips for other things you can do with long division as well. It's not going to apply to this one. I can see 47 is a prime number, so I can't break this down, which is one of the tips in my long division course. However, we're just going to do the formal written method of long division. The first thing I always suggest is to list, in fact, insist on, list the first 10 multiples of 47, which I'm going to write out now. I'm not going to teach you how to do that now. That's all in my course, but I'm just going to write out the multiples. So there I've written out my first 10 multiples. In fact, you only need your first 9 multiples, but I always write the 10th one because it's easy to do 10 times a number and it gives you a bit of a benchmark to see if you've gone wrong. So now we're just going to solve this. I'm going to zoom in just to make it a bit clearer, and I'm going to use a green pen. Okay, 47 into 6 does not go. Now you might want to prove it here. I like to just go straight to 61, but let's just do the division method where we're going to prove each step. So I need to prove that 47 doesn't fit into 6. So 47 times 0 is 0. Then I subtract 6 take away 0 is 6. And I bring the next digit down. Either way, look, I'm ended up doing 47 into 61. I like to just go straight to until I get a number that I can divide into. Either way is fine. So 47 into 61, if I look down my list, I can see it's only going to fit in once. So I put 1 in and I prove it. 47 times 1 is 47. And then I subtract it to find my remainder. And I can subtract just like I would any other subtraction. So 1 take away 7 I can't do, I need to borrow from there, that becomes a 5. 11 take away 7 is 4, and 5 take away 4 is 1. So my remainder is 14. I bring the next digit down. I now have a number 141. If I look down my list, I can see, look, 3 times it fits in, so I write 3. You would normally need to prove it. 47 times 3 is 141. So we write that underneath. we can see now that when we subtract that, that's going to be 0. So that just tells us that we've got no remainder. So that is our final answer, 13. And we can write that in our box. Question 25, 611 divided by 47. It's been written in the bus stop, so it's showing you that you do need to use this method. Now this is long division because this number 47, you probably don't know your 47 times tables, so it is long division. Now long division is an important skill to master. I have obviously got a lesson on division, long division, short division, interpreting remainders in division, all in my numbers calculation stats ebook. However, if it's just long division that you want to work on, I have a very short course on that and it's really good. It's just 5 steps and you'll be able to do long division, and it gives you lots of useful tips for other things you can do with long division as well. It's not going to apply to this one. I can see 47 is a prime number, so I can't break this down, which is one of the tips in my long division course. However, we're just going to do the formal written method of long division. The first thing I always suggest is to list, in fact, insist on, list the first 10 multiples of 47, which I'm going to write out now. I'm not going to teach you how to do that now. It's all in my course, but I'm just going to write out the multiples. So there I've written out my first 10 multiples. In fact, you only need your first 9 multiples, but I always write the 10th one because it's easy to do 10 times a number and it gives you a bit of a benchmark to see if you've gone wrong. So now we're just going to solve this. I'm going to zoom in just to make it a bit clearer, and I'm going to use a green pen. Okay, 47 into 6 does not go. Now you might want to prove it here. I like to just go straight to 61, but let's just do the division method where we're going to prove each step. So I need to prove that 47 doesn't fit into 6. So 47 times 0 is 0. Then I subtract 6 take away 0 is 6. And I bring the next digit down. Either way, look, I'm ended up doing 47 into 61. I like to just go straight to until I get a number that I can divide into. Either way is fine. So 47 into 61, if I look down my list, I can see it's only going to fit in once. So I put 1 in and I prove it. 47 times 1 is 47. And then I subtract it to find my remainder. And I can subtract just like I would any other subtraction. So 1 take away 7 I can't do, I need to borrow from there, that becomes a 5. 11 take away 7 is 4, and 5 take away 4 is 1. So my remainder is 14. I bring the next digit down. I now have a number 141. If I look down my list, I can see, look, 3 times it fits in, so I write 3. You would normally need to prove it. 47 times 3 is 141. So we write that underneath. We can see now that when we subtract that, that's going to be 0. So that just tells us that we've got no remainder. So that is our final answer, 13. And we can write that in our box. Question 26. 5,746 divided by 5. So this is a short division. I can already see that because my number doesn't end in a 0 or 5, that it's going to have a decimal, it's going to have a remainder. Okay, so I want to write my remainder as a decimal. If you don't know how to express remainders as decimals, then that is in my SATs calculation ebook. I talk all about how to interpret your remainders. So I'm going to show you how to do it now, but if you need more help on it, then do check out that ebook. So first of all, let's write it in a bus stop. I've just zoomed in to make it a bit clearer. Okay, so 5 into 5 goes once, nice and easy. 5 into 7 also goes once. There is a remainder this time of 2. So I put that there. 5 into 24 goes 4 times. 4 times 5 is 20, so there's a remainder of 4. And 5 into 46 goes 9 times. Now there is a remainder of 1, but we don't want to write remainder 1. We want to have a nice number to put in our answer box. So I'm going to extend this bus stop along the top. Now because I've got my remainder, I'm going to put a decimal into this 5,746. I'm going to make it 5,746.0. You can see the value doesn't change, does it? It's still the same number. But having that decimal means I've got somewhere to carry my remainder. So 5 times 9 is 45. So there's a difference of 1. There's a remainder of 1. My remainder is going to go now next to this 0.0. I need to put a decimal point above this decimal point here. And 5 into 10 goes 2 times. And that's how I get my answer. So my final answer is 1,149.2. So like I mentioned, if you're not sure how to divide interpreting remainders as decimals or fractions, then check out my SAPS ebook. The number calculation ebook goes through all of these different methods. Question 27, 52% of 700. Now for a question like this, there are multiple ways to find percentages. I like to break down my percentages. I like to partition them using, easy percentages. So my 52%, I would break that down into 50% and 2%. I know that 50% is half. So half of 700 is 350. And to find my 2%, I would be using 1%. Okay, 1% is just dividing it by 100. So 700 divided by 100 is 7. So if 1% is 7, that will help me to find 2%. It's going to be double. 2% is 14. So to find my 52%, I simply need to add those two numbers together. So I'm going to add 350 plus 14. Now you might be able to do that in your head. If not, just do a column addition. 0 plus 4 is 4, 5 plus 1 is 6, and 3 plus nothing is 3. So 364. Just double check mentally whether you think it makes sense. We know that 52% is going to be slightly more than half. Half is 350 and 364. Yeah, that sounds about right. It is slightly more than half. It's at this point that if you've made a really wild error, just using that estimating is going to help you to spot if there's something really wrong. Okay, so question 28, a third divided by 6. We've got another dividing fractions. Remember, when you divide by a number, it's the same as multiplying by that number that when it's been inverted. So if the 6 became 1/6, it's exactly the same. And when we are multiplying fractions, all we need to do is multiply the top and multiply the bottom. So 1 times 1 is 1, and 3 times 6 is 18. It's as simple as that. My answer is 1/18. So it's just remembering when you're dividing to take your divisor and to make that the denominator. We call this inverting it. 29 is another long multiplication. So this paper has got quite a lot of duplicates of skills. So remember, as earlier I said I like to put in my answer lines first. I didn't do this in the previous question, but what I do like to do is just put my 0 in at the beginning so I don't forget to use my placeholder. Okay, so we're first going to multiply everything by the 3. So 7 times 3 is 21. 2 times 3 is 6, plus your 2 is 8. And then I'm going to cross that 2 out. 2 times 3 is 6. And 5 times 3 is 15. We are now going to multiply everything by the 4. And I've already put my placeholder in, so I don't need to worry about that. 7 times 4 is 28. Carry my 2. 2 times 4 is 8, plus my 2 is 10. So I'm going to cross through that 2. Carry my 1. Just make sure that 0 looks a bit like a 6. So just make sure your digits are clear, because when you come to adding them up, you need to make sure that you don't make an error because of how you've written something. So we've done 2 times 4 is 8. We've done another 2 times 4 is 8. No, sorry, we've done 7 times 4 is 28. That was there. 2 times 4 is 8 plus the 2 is 10. 2 times 4 is 8 plus the 1 is 9. And 5 times 4 is 20. Right, we cross through these carried digits, and now we're going to add them all up. 1 plus 0 is 1. 8 plus 8 is 16. 6 plus the carried 1 is 7. 5 plus 9 is 14. 1 plus 1 is 2, and 2, nothing plus 2 is 2. So write each digit in carefully. 2, 2, 4, 7, 6, 1. So our final answer is 224,761. Question 30, 95% of 180. Okay, when a number is very close to 100%, what I would do is find 5% and then just subtract that. So to find 5% of 180, I'm just going to zoom in. I'd be thinking about 10% of 180. So 5%, let's find 5% equals, well, I know that 10% is just 10 times smaller. 10% is 18, so that means 5% is going to be 9. Okay, and if I just subtract that 5%, then I'm going to be left with 95%, because 100% is 180. So 180 take away 9, and I can do that in my head. You can use a column subtraction if you need to, is 171. 180, let me just label it above. 180 is 100% of the number. 9 is 5% of the number. Okay, so if I take 100% and I take away 5%, I'm going to be left with 95% of the number. And the answer is 171. So I've just taken the 5%, found that, and subtracted that from my number. Okay, if you wanted to, you could find 50%. You could find 40% by finding 10% and timesing that by 4, and then you could find 5%. So my 50% would have been 90 because it's half. 10% we've already got is 18. So 4 lots of that is 72, and then half is 9. And if you added all those together, you will find that you will also get the answer of 171, but it's a lot quicker to find the 5% and subtract that. Question 31, 0.4 times 37. So here, because we have a decimal number, you need to be very careful when you're doing your multiplying. What I would do here is I would find 4 times 37 and use that as a known fact. Okay, so I would write it out separately so that I don't forget and make a mistake. So I would use a short multiplication to find 37 times 4. So 7 times 4 is 28, 3 times 4 is 12, plus my 2 is 14. And I'd write it out there like that. Now look at 4 and 0.4. 0.4 is 10 times smaller. That means this answer needs to be 10 times smaller. So it's going to be 14.8. Okay, can you see that? 0.4 is 10 times smaller than 4, so my answer needs to be 10 times smaller. That is my final answer. Remember to write the correct final answer in. Don't write in 148. 14, make your decimal point very clear, 0.8. Question 32. 1 subtract something is 7/10. So remember, when we are subtracting, these two numbers can be changed. So if we think about it as 1 subtract 7/10, we will get our answer. Now remember, when we're subtracting or adding with fractions, we need our denominators to be the same. So let's give our number 1 a denominator of 10. Now remember, 1 is just when the numerator and denominator are the same. So instead of writing 1, we could write 10/10, and we can subtract our 7/10. Once we've got denominators the same, we know that our answer is going to have the same denominator. And then if we look at our numerators, 10 take away 7, very simple, it's 3. So 1 take away 3/10 makes 7/10. And if we use a bit of inverse to check our calculation, does 3/10 and 7/10 added together make 1? Well, yes, they do. 3/10 and 7/10 make 10/10, which is the same as 1. Question 33, we've got another long division. 4,472 divided by 26. So the first thing I'm going to do is just write out my 26 times tables. Okay, I'm going to pause and fill them in. And then now I can start to do the actual calculation. So 26 into 4 doesn't go. 26 into 44, if I look down my list, it doesn't quite fit in twice. It only fits in once. So I'm going to subtract 26 times 1 from my 44, and that is 18. I'm going to bring the next digit down. Look down my list, I can see it goes in 7 times. 8 times is too many. So I write 7 at the top, then I write what 7 lots of 26 are, which is 182, and I subtract that, that's 5. I bring the next digit down, and now I'm looking for 52. I look down my list, I can see it fits in 2 times. I'm just going to prove that, write it underneath, subtract it, and I've got to 0. I know there's no remainder, I've got my final answer. And my final answer is the number at the top of the bus stop. Don't forget to write that in. The final answer is 172. Question 34, okay. 2 and 5/6 subtract 3/4. So we've got our first mixed number subtraction. Now with these subtractions, when I'm subtracting fractions and there's a mixed number, I always convert my numbers to improper fractions. Okay, I don't try and partition at all. So I'm going to change my 2 and 5/6 first of all to an improper fraction. If you don't know how to convert mixed numbers to improper fractions and vice versa, then you do need to check that out. It's a really important skill to learn. So check out my fractions ebook if you're not sure on that skill. So I'm just going to quickly convert. So 2 and 5/6 is the same as 17/6. Now the next thing is, I spotted that these don't have the same denominator. So if I just wrote this out again, take away 3/4. I've spoke earlier on about how I always check if my smaller denominator can fit into my bigger denominator. Now 4 is not a factor of 6. Okay, so 4 is not going to multiply up to make 6. So I need to find a common multiple. Now you might multiply 6 by 4 and make both of these 24, but I can see there's a smaller common multiple, which is 12. So you could change both these fractions to 24, but I'm going to change them both to 12. So I'm going to rewrite both of them as fractions out of 12. So my 6 needs to double to make 12. So my 17 is going to double to make 34. So 17/6 is the same as 34/12. My 4 needed to triple to make 12. So my 3 is going to triple to make 9. 9/12 is equivalent to 3/4. What I now have is the same denominator, and I also don't have any whole numbers there. My mixed numbers become an improper fraction. It's going to be a lot easier to subtract now. So I know that my denominator is going to stay the same because that stays the same all the way through. So all I need to do now is just do a subtraction. Just 34 subtract 9. And 34 take away 9 is 25. Okay, now that I have my answer, I need to change back from my improper fraction to a mixed number. I know that 25/12 is an improper fraction because it's top heavy, the numerator is bigger. So I think about how many 12s fit into 25, and that is 2, with a remainder of 1. Okay, so like I said before, if you don't know how to convert between mixed numbers and improper fractions, do check out my calculations. My number fraction SATs ebook. So my final answer is 2 and a half. Not a half, 2 and a 12th. 2 and 1/12. Question 35, 38% of 750. So as I said before, there's lots of different ways with calculating percentages, and I go through all of it in my SATs ebook. You can find lots of stuff on how to calculate percentages. Now you could find 30% and find 8%. But to find a 30%, you're going to need to find 10%. And to find the 8%, you're going to need your 5% and your 1%. What I would actually find quicker in this instance is to just do some multiplying, but you need to use what you find quickest for you. I'm going to just do 750 multiplied by 38, because 38% of 750 is the same as 0.38 times 750. They are the same thing. If you were finding 38% of 750 on a calculator and you didn't have the percentage button, which you would, but that's what you would type in, 0.38 times 750. So I would actually just do a long multiplication because I think that's going to be quicker in this instance. I put in my sections and I put in my placeholder. So 0 times 8 is 0, 5 times 8 is 40, 7 times 8 is 56, plus 4 is 60. 0 times 3 is 0, 5 times 3 is 15, 7 times 3 is 21, plus my 1 is 22. Add it all together, 0, 0, 5, 8, 2. Now I need to divide that by 100 because that is 750 times 38. I want 750 times 0.38, so I need to divide it by 100, which means I'm going to get rid of these last two places. So I've got an answer here of 285. Let's just check it with the other way. 10% of 75. Bear me one moment while I just move this over. So 10% would be 75. 5% is half of that, so that's 37.5. And 1% is 7.5. So to find 30%, we would need to times 75 times 3. And you can already see it's a lot more long-winded. So let me move these over as well. 30% would be 75 times 3, so that's 225. I am doing this in my head, obviously, but you can write this down to check it if you need to. And then if 30% is 225, then 3% is going to be 22.5, plus the 5%, which is 37.5, is 60. Oh, bear in mind, bear with me with the very messy writing. There we go, 60. So 225 plus 60 is 285. It's the same answer, but it's a lot more long-winded, and you would have to do a lot of calculating to do the 75 times 3 and then adding the 37.5 plus the 2. So in this instance, I think it's a lot easier to multiply the two numbers together, to change that 0.38 to 38, and then just make sure that you divide the answer by 100 at the end. Okay, and then write in the final answer in the answer box, 285. Question 36, 2/3 times 900. Now, if this question confuses you, the easiest way that I've found to explain this is to just change the times to an of. So 2/3 of 900. This is actually a fraction skill that you will learn before year 6. Okay, I think it's in year 5, year 4, year 5 that you learn how to find multi-unit fractions of a number. So to find 2/3 of 900, you're simply going to find 1/3 of 900. You'd actually do this in one step, but I'm just writing it out in 2 steps by dividing it by 3. So 1/3 of 900 is 300, and then 2/3 is, you're then just multiplying the answer of 300 by 2. So if 1/3 of 900 is 300, so you divide it by 3 is 300, times it by 2 is 600. If you're not sure how to find multi-unit fractions of a number, then you can check out my SATS ebook, the fractions one, or you can have a look at my year 5 booster course, which also has lots of fraction skills. And I also have a fractions foundation course, which goes through all the fraction skills from year 3 up to the end of year 5. So our final answer is 600. So I hope you found that walkthrough helpful. Remember, if there are any skills that we've gone through today that you are unsure of, I've got resources on everything. So you can check out my Year 6 SATS ebooks, or there are the other standalone courses, the Arithmetic Academy, focus on fractions, there's Fractions Foundation, there's the Long Division Challenge. I will link everything in the description and in the comments. If you're looking for some effective revision to help you with your maths SATs, then check out the Pocket Private Tutor Shop. I have SATS ebooks and I have revision courses. The SATS ebooks cover every single thing from the Year 6 national curriculum, so you can be sure that nothing will appear in the paper that you haven't learned. Each ebook comes with a video which you can watch on a laptop, on a tablet, on your phone. You can even cast it to your smart TV if you want to watch it big. I have worksheets to help you practice the skill, and included are past SATS question examples. That means when you're learning a new math skill, I also include how that has looked in an actual SATS paper before. I also have some revision courses, I have practice arithmetic tests, I have loads of stuff that's going to help you to absolutely smash your SATs. So check out the Pocket Private Tutor Shop and download the course that's going to help you now.